All right, let's go ahead and get started. I want to welcome you to Unit 6. This is nomenclature. This is one I really think you're going to enjoy because it really involves a set of rules or rules that are going to help us to be able to name chemical compounds, which is obviously an important skill in chemistry. So I want to start with covalently bonded compounds, what we call binary molecular compounds. Binary, of course, meaning two, molecular meaning that the molecule is covalently bonded. Now, remember that covalently bonded compounds are those that are formed by elements from the right-hand side of that zigzag line on the periodic table, but we have to remember the exceptions to that rule, and that is hydrogen. Hydrogen is on the left side of the zigzag line, but for covalently bonded compounds, hydrogen is included. So hydrogen is part of a covalently bonded compound. The basic unit of covalently bonded compounds is called a molecule. We've mentioned that, thus the name binary molecular, right? So if we have a molecule, that's the basic unit of covalently bonded compounds. Now, that means that covalently bonded compounds involve a nonmetal and a nonmetal. In other words, two things from the right of the zigzag line on the periodic table. So to make covalently bonded compounds, you must first memorize a set of Greek prefixes. They're not hard. In fact, you might know most of them. 1 is mono, 2 is di, 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Let's go through that again. 1 is mono, 2 is di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So these are the prefixes that you'll have to have in your head in order to be able to name covalently bonded compounds. They're not hard. So now we're going to need to know a few rules for naming these covalently bonded compounds. So let's take them one at a time. Let's take a look at this first rule. Rule number 1, name the least electronegative atom first and then the more electronegative atom, okay? So the least electronegative atom goes first and then the more electronegative atom. So for example, if we wanted to name this atom or this molecule right here, CCl4 is a covalently bonded compound, but we wouldn't do this. We wouldn't say Cl4C because the least electronegative atom is going to be the carbon right there, right? It's less electronegative than is the chlorine. So we would do this, CCl4, and not this, okay? So that's the first rule. Got it? All right, let's do the second rule. If the first atom is present only once, then don't precede it with the mono, but otherwise place a prefix before it. So if we have a compound, for example, like this one right here, CO, we're going to call that carbon monoxide, but we don't call it monocarbon dioxide because rule number 2 again says that if you've got only one for the first one, and we do in this compound right here, you don't put the mono in front, but you do put the mono for the second one. So we're going to call this one carbon monoxide. Carbon monoxide, just like that. All right? Makes sense? Let's go on. Let's take a look at this third rule here. It says place the correct Greek prefix, including the mono, before the second atom. All right? Now, rule number 4. Replace the ending of the second atom with IDE. All right? So there's 4 rules. The last one is replace the ending of the second atom with IDE. Let's use what we know now to name these compounds. I put the answer there so you can just check yourself. We'll do some more practice in just a moment. So let's practice the following covalent compounds. But I want you to look down the list, though, and convince yourself that these are bimolecular. That means that they're involving 2 different types of elements. That's first of all. And that we've got they're both nonmetals, right? So for example, carbon and oxygen are both to the right of that zigzag line. Nitrogen and oxygen in the third one down also to the right of the zigzag line. So let's name them. So we have C and then O. What do we call that? Well, we call that Again, we've looked at this one already. We don't call it monocarbon monoxide, but we simply call it carbon monoxide. Carbon monoxide. So that's the first one. Let's look at the second one. We have CO2. So this time we have two oxygens, right? So CO2 would be carbon dioxide. Carbon dioxide, just like that. So that's the second one. Let's look at the third one. We have dinitrogen. There's two nitrogens. Pentoxide. We often don't put two vowels. If you do put both the vowels together, if there's two vowels together and you put them both, it's not the end of the world. But generally speaking, we drop the first vowel. So this would be dinitrogen pentoxide. Pentoxide, I'm sorry. If you put pentoxide, that's okay. It's not a big deal. But it's preferred that you drop that first vowel. All right? So dinitrogen pentoxide for that third one. Let's take a look at the fourth one. We have ICl3, that would be iodine trichloride. Iodine trichloride for the fourth one, right? Iodine trichloride. Tri is 3. This time we've got 2 phosphoruses and 5 oxygens. So we would call this one diphosphorus pentoxide. Diphosphorus pentoxide for that one. CCl4, we looked briefly at this one just a few minutes ago. CCl4 would be carbon tetrachloride. CCl4, tetra is 4, so carbon tetrachloride. And finally, H2O. Now, we're generally going to call this water, obviously, but we can also name it. It's dinitrogen monoxide. Dinitrogen monoxide, okay? All right, now let's practice going the other way. Let's take the formula and write the name. What if we have NH3? What would that be? Well, NH3 is nitrogen trihydride. Notice there's an IDE at the end of every single one of them, right? But we generally don't call it nitrogen trihydride. NH3 is ammonia, and I'll expect you to remember that, okay? The next is BF3. This would be called boron trifluoride. Again, don't call it monoboron trifluoride. It's just boron trifluoride. The tri, of course, being for the 3 fluorines. NO2, what would that one be? Nitrogen dioxide. Di for 2, right? So nitrogen dioxide. The next one is SF4. Sulfur tetrafluoride. Sulfur tetrafluoride. SF4, sulfur tetrafluoride. Next one, CS2 would be carbon disulfide. Carbon disulfide. Cl2O7, what would that one be? Dichlorine heptoxide. Dichlorine heptoxide. Notice this time I left that first vowel in there, the A. That's okay again, but it's really preferable not to do that. But I just wanted to put that so that you could see that it's kind of optional. Most people don't put it, but if you put it, it's not the end of the world again. The last one is N2O9 dinitrogen dinitrogen, not monoxide, nonoxide, right? 9 is nano, right? So dinitrogen nonoxide. So that's the last one. All right, now let's do this. Let's talk a little bit about naming simple binary ionic compounds. So we've talked about covalently bonded compounds. We had some things to remember, but some prefixes to remember, but they really weren't that difficult, were they? But now let's shift our attention to simple binary ionic compounds. That means compounds in which there's a transfer of an electron. So we're talking now about metals and nonmetals, right? Metals and nonmetals. Now, what do we mean by simple? Well, by simple, we mean that there are no transition metals involved for now or polyatomic ions. So we'll learn about how to do those in just a little while. So ionic compounds are formed between metals from the left side of the zigzag line and nonmetals from the right side of the zigzag line. Metals and nonmetals, remember, for ionic compounds. Now, if the metals involved are not transition metals, then naming the ionic compound is extremely easy. All right, even easier than covalently bonded compounds. All you have to do is name the cation, that's the first one, and then name the anion, that's the second one. Replace the ending of the anion with "ide." That's it. You're done. Cation, anion, then ide. That's it. So let's take a look at a couple of examples here. Let's name the following simple ionic compounds. I want you to convince yourself, though, that these are ionic. Look on the periodic table. You should have one in front of you right now. If you don't, pause the video and get one because you're going to need it from this point forward. So, NaCl. See how Na is on the left, right? It's one of the alkali metals. Chlorine is on the right. It's a halogen. So that would be sodium chloride, right? No prefix is necessary. The cation, then the anion, IDE, and you are done, right? It's just that easy. MgCl2, we've got magnesium and then chlorine. You in your naming of this ionic compound, you don't have to in any way signify in the name the fact that there's a subscript of 2 after that Cl, okay? You don't need to worry about that. You just name the cation, the anion, IDE, and you're finished with that one. Let's look at the next one. Calcium bromide, CaBr2. Calcium bromide for the third one. Again, 1 calcium, 2 bromines, but it doesn't matter in the naming. You just say the cation and then the anion and add IDE. This is for ionic compounds now. Next one, MgO, magnesium from the left, oxygen from the right. We've got magnesium oxide. Magnesium oxide. Next one, SRSE, strontium selenide. Strontium selenide. Okay? All right. Next, K2O. K is potassium, right? Potassium oxide for this one right here. And the last one's going to be Mg3N2. This is going to be magnesium nitride. Now, let's go back and ask this question. How did I know to put these little subscripts after? Like, how did I know to put a K2O? How did I know to put a Mg3N2? How did I know to put those subscripts there? Well, remember, if I give you the formula and just ask for the name, you really don't have to worry about that, right? If I put the subscript there, it's because it needs to be there, okay? And that's all you need to know. All you need to know is it covalent? Is it ionic? If it's ionic, you let me put the subscripts wherever if I'm writing the formula, you let me put the subscripts wherever I want to put them. And you just make sure that you know the rule for the naming of that ionic compound, okay? Now, just in a couple of minutes, though, you're going to have to, in fact, in the very next screencast, you're going to need to know how to write those in, all right? You're going to need to know how to write those in. But I think we'll call it quits for this one right here. We'll pick it up on the next one, and we're going to be looking next time at how to write the formula if I give you the name. Again, you're going to need a periodic table for this one, so if you don't have one handy, go ahead and get one now. All right, I'll see you in the next one. Thanks.